Hello, I'm going to explain you today the ultrasonic pulse velocity tester, which is a pocket model manufactured by Matest, Italy, and marketed by us. The entire package, what we are providing along with the pocket ultrasonic pulse velocity tester, is basic instrument, which is a pocket handy, a couple of ultrasonic probe, 55 kilohertz, which comes standards along with the ultrasonic pulse velocity tester, and there are two more frequencies available as options. These are 120 kilohertz and 24 kilohertz. Sorry, 150 kilohertz and 24 kilohertz. Then we are providing a contacting paste, which is very essential for acoustic contact between the ultrasonic probe and your concrete surface material. A standard calibration rod, which has a calibrated time of 42.5 seconds, travel time of 42.5 microseconds, two connecting cable, 4 rechargeable cells, then there is a power cable to recharge your battery cells, and there is a data transfer cable, and all kept in carry case. So what I'm going to show you now first is to put the battery, recharge the cells. It is given inside a plus and minus sign, so you can put it accordingly. Please ensure that these are the double size rechargeable cells. If you are putting a non-rechargeable battery inside, a standard battery inside, if at all you found is missing or it has been used for a long period of time, and then you wanted to use, you are not finding a rechargeable cell in the market, and you just wanted to use a non-rechargeable, then ensure that all the four cells are non-rechargeable. Don't use 2 rechargeable and 2 non-rechargeable. Use all 4 non-rechargeable, and don't use this power cable to charge that, because you are using non-rechargeable cells and then you are trying to charge it. So don't do that. Further, don't try to connect this pocket ultrasonic tester to the main 230 volt power supply without cell inside. So these two things you should take into consideration. So I am now putting the batteries inside, which are the rechargeable batteries. So I have connected all the 4 cells, putting back the cover on. TX, RX, trigger and scope. Connect these two cables at TX and RX respectively. You can connect because both the cables are the same, so you can connect anything anywhere. So I'm just connecting this cable to TX. You can see I've just put it and just twisted it a little bit. Similarly here to the RX. Another end connected to the ultrasonic probe the same way. 55 kilohertz probe. Both are 55 kilohertz probe. Now this trigger and scope are the external connector. If at all you wanted to see the waveform of the pulse transmitting through the material, you can connect one cable from the CRT to the scope and another one more cable for the triggering. So these two cables are required coming from the CRT to be connected to the ultrasonic pulse velocity tester. So now we have battery cells inside. I have connected the ultrasonic transducers, and now I am just starting the UPV tester by pressing the F1 key. It shows the company's name, Matest, version, and this is the main menu. So on the main menu you can see it shows you a date, time, battery, date, time, battery, and then previous values of the ultrasonic, the timing, travel time, mode of measurement is a continuous mode or a single mode. Okay, now the language is in Italy, so I have to change the language. So the first one, which is a right arrow key, is a start of the test. So if you press this, it will start taking the measurement. So now this start with reference to F1. This shows a setting key, that is some parameters. So you can press F2. Then the third one is your saving of the data, and fourth one is sending the data to the external computer through this connecting cable. So I am pressing F2 to enter into the data and first of all change the language. Okay, now this scroll key, you can see this elliptical one, you can use F1 key to scroll through, and I'm coming to the lingua, which is a language, and then selecting it with plus key English. So now it has changed to English, and again scroll through, coming to the date. So today's date is, I can just change the date, plus and minus key to select the month, then again scroll through, select the year, it's already 2016, then select the time. So it's hours basis, 1830, select more, scroll through, 1837. Okay, fine. So mode in continuous, there are two modes of operation. Either you can do it in continuous mode or in single mode. In either mode, the transmitter transmit continuously the pulses of ultrasonic pulses, but the pocket ultrasonic pulse velocity tester records four times in a second the signal transmitted and received by the receiver. It checks the value of those 4 readings if within the range of the instrument. If not, then it discards the reading and take the another 4 reading in a 1 second. And also it shows whether these 4 readings are consistent. That means one value obtained, let's say 20 seconds, and another value obtained at 80 seconds. So inconsistent, so it doesn't take that. So, and then it averages the 4 readings and displays the value. In continuous mode, it does the same way, but it does 3 times and then records it and keeps on continuously measuring the value as long as you do not press the stop key. So you can select continuous mode or a single mode by up, down arrow key or up arrow key. Continuous, single. Now go to the scroll key, go to another panel, save. Yes, if you keep this function yes, that means that it's the automatic saving of your data. It keeps on saving the data. Next function is a gain. Now gain is selectable between 750, 500 volt to 50 volt and 1000 volt. When this gain is required, usually we do the measurement in a cross probing. That means there is a concrete structure and you keep this probe across the structure. Sometimes the another face is not accessible, then you do the measurement like this. That means this is your surface probing. Now the surface probing, usually the signal amplitude is very weak and the results may vary quite significantly. Now there is bound to be some error when you do a surface probing where there is no possibility to do a cross probing like this. But to minimize the error, we can increase the gain by keeping the gain value of here to maximum 1000 volt. By doing so, we can try to reduce the error encountered while probing surface probing. So that is for the gain. Then coming to the next parameter is a language. Obviously it's English. We don't have a Hindi language selectable over here. Then the sample. Now its value has already been fed inside 42.5 microsecond. Now this is what is this we are talking about. 42.5 microsecond. And then I have changed the value. Okay, I'm going back to 42.5. And then the calibration menu. Now this calibrate is whenever you are doing a fresh sample, it is essential you first verify your sample, verify against your standard. Now I am not going to the calibration now. I am just doing one test. So I am just escaping out of this particular menu by pressing the F4 key. Escape F4. This is the main menu. Now if I press this key, that is F1 key, it will lead me to a start of the test. Now I am measuring the ultrasonic pulse velocity across the standard. So it should give me a time in microsecond exactly equal to 42.5 microsecond. Now the first and foremost thing, apply sumptuous quantity, because this acts as a contacting medium, acoustic contact between the two different surfaces. That is your ultrasonic probe and your surface. So I'm just applying on this surface also, putting this, and on this surface also contact medium, putting this. Okay, now I press start key, that is F1. Okay, it's showing 40.5 microsecond. Now actually its value 42.5 microsecond. So this leads me to calibrate the my ultrasonic pulse velocity. So I will now calibrate it. You can see 40.4 or something. I can still do it once again. Just verify it. It's coming here. It's still coming 40.3 and 44. So what I do, I go to the setting parameters, go to the calibrate by using a scroll key. Oh, it is gone. I have to just again scroll back and then select by plus or minus key. Now what it is asking, you can see that it is mentioning that bring the probes in contact and press start key. So without the sample, it's asking me to bring the probes in contact. So I am bringing the probe in contact. Okay, now press start key. So F1 is the start key. Still the process is going on. So nothing, just press stop key after this. So F1 is acts as a stop key. Whatever the value, just note down, but make sure that there is a good contact. Now the another message comes, insert a sample and press start key. For our calibration, our sample is a 42.5 microsecond standard rod. So I put the standard rod in between and press start key once again. Whatever the value, press stop key. So now this has been calibrated. So you can test it now by pressing this. It should give you the exact value. Now that means my machine is now ready to take a test. You can now take test on any of your sample in a cross probing. Ensure the minimum distance is around 150 mm. 55 kilohertz is the standard all-purpose ultrasonic probes available. And if you want to have a more accurate one for a smaller size or smaller distance sample, you can use the higher frequency probes of 155 kilohertz, where you can do it less than 50 mm or 100 mm length of your sample. But it is, as is mentioned in the Indian test standard or European test standard, 55 kilohertz is a normal, usually used everywhere. Now, why it is required? I mean, what it does, it gives? It gives you time of flight, time of travel. So there is a transmitter which transmit the ultrasonic pulse waves. Now ultrasonic pulse waves, when it gets transmitted, it goes into the sample. Now when it goes into sample, depending upon the type of the sample or geometry, there is a complex waves are created. It could be a shear waves, it could be a longitudinal or compressor waves, it could be a surface waves. Now there is a complex of these waves. Now what does this ultrasonic pulse waves measures? Is a compression waves, longitudinal waves, because of its ability to measure these compressive waves, which are independent of the geometry of your sample, and it depends more on the elastic properties of the sample which you are testing. So it is possible to calculate the dynamic modulus of your sample by knowing the pulse velocity. You can easily calculate the dynamic modulus of elasticity of your sample. So it may be used, now this may be used as a non-destructive test method to evaluate the dynamic modulus of elasticity of your sample by knowing the velocity of travel. Now how you calculate the velocity of travel? You know the time of travel in microseconds. You know the distance between the two probes, that you can measure it at any site. Now by knowing the distance and by knowing the time, you can very well calculate the velocity, distance upon time. Now after calculating distance upon time, now this velocity obtained can be used to calculate your dynamic modulus of elasticity. For that, there is a formula given in your IS standard, and the formula says that E equal to mu function of, rho function of mu v square. Now function of mu is nothing but your Poisson's ratio. Now Poisson's ratio is between 0.2 to 0.35. So you need to know the Poisson's ratio, you need to know the density. Then by knowing the velocity thus obtained from the ultrasonic pulse velocity, by knowing the time of flight and the distance between, you can calculate the velocity. You can easily calculate the dynamic Young's modulus of elasticity of your concrete sample. Now, since you know the velocity, it is a good tool. You can easily estimate the uniformity of your concrete sample, because the standard states that if your velocity in kilometer per second is more than 4.5, then it's excellent concrete. If it is between 3.5 to 4.5, it's a good concrete. If between 3 to 3.5, it's a medium, or below 3, it's the doubtful concrete. So it can be a very easy tool to know the quality of the workmanship, whether it is being uniformly laid on the surface, so that there is no heterogeneous or there is no internal crack. So it can be very useful tools even after the laying of the concrete. You come to know if there is any heterogeneous at any point or at any place of the surface. Or you can use it can be used to evaluate your concrete structure, which is very old structure. Over a period of time, there are internal cracks are being developed, because ultrasonic waves it travels at very low speed in air. So the travel time increases, hence the pulse velocity decreases. So far I explained you this what it does. I mean, you know, you have a 55 kilohertz probe. You know, I have a calibrated sample of 42.5. So every time if I check this for its value 42.5 microsecond by pressing the F1 key, yes, then I'm sure that my equipment or my instrument is measuring correctly, so my instrument is ready to take any test. So with this you can go and take the test. Only precautions to be taken, that if this falls off or something goes mechanically wrong, because these are likely to get fall, because you need at least one person handling, ensure that this doesn't fall off. All the joints are electric cable, make sure that it's intact. And one more thing is that always ensure that if you are using the rechargeable battery, use the rechargeable battery and then charge it with a 230 volt charger, or don't use a rechargeable. If you are not using rechargeable, don't use this. And if it is empty, there is no cell inside, don't run it on the 230 volt. These three things you have to take into consideration. Thank you.